Welcome to Integration, Apache Flink, Apache NiFi, and Apache Kafka. I'm Timothy Spann. I'm a Principal Data Flow Field Engineer at Cloudera. I also run a meetup group in Princeton. I work with Kafka, Spark, various technologies in the cloud, as well as deep learning. Today we're going to take events from some source, process them through NiFi and Kafka, and then use Flink to do some advanced real-time processing on there, and then store it to a data store. Pretty simple, but this could be in a Kubernetes environment. This can be in a single cloud, public cloud. This could be in a hybrid cloud environment, multiple clouds. This could be advanced because you're pulling, it could be logs, it could be from a relational database, could be from a NoSQL store, could be from sensors, could be from smart cameras, phones, wherever you have data, grabbing that data as it happens, event at a time, and it could be a batch of events at a time. These could be, 10 records a second. It could be 1 million or 1 billion events a second. We're taking these in, processing them, and then we could show you, we could route them to different sources, whether a front-end mobile application, to a data store, to another program for processing, to a report, to a Slack group, wherever you need to send this data and do it real time. Flink is one of the tools. I'm going to show you it in demos so you get an idea. You can browse these slides at your leisure, but I want to show you real data as it's coming through the system. So I have a device sitting in my office producing data, and I'll show you something really nice with this is being able to see what's happening as it happens, because when you get a lot of events from a lot of different sources, it may be hard to see what's going on. Within Apache NiFi, we have something we call provenance. This tells me when an event arrived. It has built-in auditing, so I know the size of a unique ID for it. I knew what it is, what it's doing, where it came from, its size, and I can view the actual data. This is JSON that has sensor values in it, and that's going to be routed through my system. If it's energy data, I route it one way, sensor data another. So first thing we do is we get some energy readings. They're JSON. I automatically can infer the schema, though in a system with data that doesn't change constantly, you could create your schemas, put them in a schema repository, so I could instantly know all the fields and types for that. So I could do validation, see if something's supposed to be null, those sort of things. And then at the end, I convert it to JSON, but I can convert it to Avro, XML, CSV, whatever format you need for your next system. While I'm doing that conversion, I'm also doing some simple SQL. I could do more advanced SQL. I could do summaries, aggregates. I could just pick certain fields. I could have extensive where clauses. And I could have as many of these as I need for routing wherever the data needs to go. For here, I'm just looking at one of the sensor fields to know fan is off on that energy device, or the fan is on. And from there, I'm pushing it to Kafka, which is the second piece of the puzzle. Keep an eye on this one. I'm putting it into a topic called energy. Kafka is a messaging queue for the cloud that lets me push events anywhere they need to go at scale with security, durability, high availability, things you need to do when you're doing these real-time systems. So we have that energy data in an energy topic. Then we have data coming over here that I'm also running a query on. This one's slightly more complex because I'm taking a value, converting it to a float, looking to see if it's greater than a certain temperature, and then I can send that information to a machine learning model. But for now, every single record I get in from the sensor, I'm going to push to another Kafka topic. This one is SCADA. Let's remember that. Another thing I mentioned real quick is I could send data to different places. So one thing I'm doing with that data is sending it to a Slack channel so that data can be shared with my colleagues in case certain things come up. So I'm looking at it now. This is those sensor readings. So it's a good way to monitor them. Maybe I send every certain events there or anomalies or alerts, to my team there, and they can take a look and see all the values. Okay, this is where it came from, IP address, these were the values. Great for debugging or testing, or just for notifying people when my data has arrived. Great feature to have there. So we pushed it there. We also pushed it to Kafka. A final thing we're doing in another flow is we're pushing the data that comes in to a data store. Now this one I'm pushing it to a Kudu table within Impala. It could be a Hive table, it could be a table in Oracle or SQL Server or Redshift or Snowflake, or I could push it to any number of data stores. It's very easy for you to push it to one or more of these data stores in a single click. Put in my information for Mongo, now it's in Mongo. I could push it to an object store. I could push it to HBase, Coachbase. There's a ton of places I could send this data, just to give you an idea. But for now, I pushed most of that data to Kafka, which is our environment for messaging. We take a quick look here. I mentioned SCADA for sensors, and I mentioned energy for the energy ones. So we could take a look. You could see that data is coming through the system, and I can examine the most recent records to see, okay, this is the data that's coming through. This is JSON data. Okay, I get an idea. Data is coming through the system. I'm getting some of the data for sensors is coming through as well. That just came through. Again, I can look at the data. Gives me a way of seeing how those messages are coming through the system. There's also another topic here that I'm not populating from NiFi, this global sensor events. And if we look at this one, again, we're using Cloudera's SMM so I can look into those Kafka messages. Otherwise, it's just a message in a queue. It's nice to be able to browse it, see all the data about it, where it is. It's great for, developing and tracking these distributed cloud applications. It's kind of difficult otherwise. If we look at this, this is a combination of fields from both of those things. So how did we do that? I pushed it to Kafka. On the other end is a Apache Flink app. The app is this right here. That's all the code I wrote. Now I could wrap that in a Java or Scala app like you do in Spark, but through my command line SQL client, I could just create this SQL, and it creates a distributed job using that SQL syntax to do an insert into this Kafka topic that I created as a table, and that is to select some of these fields from the SCADA topic and some of these fields from the energy topic where they have the same system time. When that happens, the source from this one and the source from this Kafka topic get joined together and put into this third one. And we could see the records coming through, how many have been inserted. And we can take a quick look in Flink. This is our SQL interface. It is pretty simple, but it lets me write these without having to write a special job for that, which is nice. But as you see, the data is coming through the system. We saw it getting inserted into this Kafka topic, which was being fed by these two here. And what's interesting here is if I want to trace this to see what's going on, I could do that by looking at who's using it. The consumer of this is Flink. It's getting produced by NiFi, coming through this partition in this topic. A broker is what they call one of the nodes in a Kafka cluster. So this data is coming through the system while we're doing it, and I can do a SQL against that Kafka topic right here, so I see those records being loaded while it happens. And we can look at, previous values from this, and I could go in and examine one particular record to see what's going on the time. This is great for debugging. This can be inside an application that's feeding a live report. This can be inside of a microservice, whether I do that with Kafka Streams or with Flink or Spark or Spring Boot, wherever you might want to do that, and display this data while it's coming through the system. It's a great way to do this with very little code.
you.